This is Cambridge International, March 2021, Paper 3, version 2. Question 1 wants us to solve this equation. Often with these questions it's a good idea to take the powers up first. So that's what I'm going to do on this side. I'm going to make this log x cubed. And then I've got two logarithms subtracted. So I'm going to combine them into one by dividing x cubed by 3. I can now take exponential of both sides, giving me x cubed minus 3 equals x cubed divided by 3. Let's clear the fraction. So 3x cubed minus 9 equals x cubed. We'll subtract x cubed. So 2x cubed minus 9 is equal to 0. So 2x cubed is equal to 9. X cubed is equal to 9 divided by 2, or 4.5. And now we're going to cube root that. And it asks for our answer to 3 significant figures. So 1.65, let's just double check. Yes, 3 significant figures. Question 2 looks like a factor and remainder theorem. So first of all, because x plus 2 is a factor of p of x, that means when I substitute minus 2 into this, I should get 0. So that's what I'm going to do. A times minus 2 cubed plus 5 times minus 2 squared minus 4 times minus 2 plus b, that is equal to 0 because it's a factor. Minus 8a plus 20 plus 8 plus b is 0. So minus 8a plus b, this is 28, so when we subtract it from both sides we have minus 28. That's going to be our first equation. Now when it's divided by x plus 1, I realise I wrote an f there, it should have been a p, never mind. Let's fix that actually. So when it's divided by x plus 1, the remainder is 2, so that means when I do p of minus 1, the answer is going to be 2. So same thing again, a times minus 1 cubed plus 5 times minus 1 squared minus 4 times minus 1 plus b, and the remainder is 2. So minus a plus 5 plus 4 plus b is equal to 2. So minus a plus b is equal to 2, subtract 9, so minus 7. And there's a few ways to solve this. I think this one's easier to solve by elimination. So I'm going to do equation 2 take away equation 1. Minus a minus 8a is 7a, minus 1 plus 8 is 7. b subtract b is nothing. Minus 7 subtract minus 28 is plus 21. So we get this nice answer that a is equal to 3. Let's substitute that into number 2. Minus 3 plus b is equal to minus 7. Add 3 to both sides. And we get b is equal to negative 4. And that's all we're asked for. There we go. Question 3 is a trigonometry question. It wants us first of all to express it as a quadratic equation in tan x. Now let's start by changing our cot x then into 2 over tan x. And this, as soon as you look at this, hopefully you're thinking, well, I need to look in my formula book. Let's look for that addition formula. There we go, it's this one here, tan a plus b equals tan a plus tan b over 1 minus tan a tan b. So tan x plus 45 equals tan x plus tan 45 over 1 minus tan x tan 45. Tan 45, you can check on your calculator, is equal to 1. So let's change that to 1. Tan x plus 1 over 1 minus tan x is equal to 2 over tan x plus 1. There's a few ways we can now try and rearrange this. Perhaps I'll multiply by everything by 1 minus tan x first. Plus 1 minus tan x. And now let's... we could multiply by tan x next. I'm tempted to simplify first because I have minus tan x here and tan x here, and I have a 1 on both sides, just to save me a little bit of work later on. It doesn't really matter, but I'm going to add tan x and I'm going to subtract 1. So here I get 2 tan x. Subtract 1 from both sides and we get nothing. Divided by tan x, and then multiply up by tan x. And we get 2 tan squared x equals, and I'm going to multiply the top out at the same time, 2 minus 2 tan x, and let's get it all onto one side, and let's also divide by 2 at the same time. Tan squared x plus tan x minus 1 is equal to 0. So we've expressed it as a quadratic. Let's just double check again what the question asked for. It wants us to solve it in the domain 0 to 180 degrees. Okay, so it doesn't seem like this is going to factorize, so maybe I'm going to write let y equal tan x, and we have y squared plus y minus 1 is equal to 0. So a is 1, b is 1, c is minus 1. So we use the quadratic formula. So we have minus 1 plus or minus the square root of 1 plus 4, so square root of 5, divided by 2. So we have either tan x is equal to minus 1 plus root 5 divided by 2, or tan x equals minus 1 minus root 5 divided by 2. So let's do inverse tan of that. Minus 1 plus root 5 divided by 2. And we get 31.7 degrees. And then let's see if we can, delete that, change that to a minus sign. And here we get minus 58.3 degrees. Now that is not in our domain, so let's draw our cast diagram. Okay, the the angle minus 58.3 degrees is here. So tan x is negative in this quadrant. The other quadrant where it's negative is this one here. Oops, it's not the correct angle that I put on there. So we can either add on 180 degrees to minus 58.3, or we can do 180 subtract 58.3. So 121.7 degrees. Let's make sure those stand out for the examiner. Okay, question 4 wants us to solve this differential equation. So we're going to do this by separating the variables, by multiplying and dividing. So I'm going to divide by y, and I'm going to divide by 1 minus cos x. So when I do that, oops, I forgot my y there. So 1 over y dy is equal to the integral of sin x divided by 1 minus cos x dx. So let's now integrate. On the left hand side I get ln y. On the right hand side you'll notice, or hopefully you'll notice, that when we differentiate 1 minus cos x we get sin x, which means that this also takes the form of ln 1 minus cos x plus c. Okay. It's useful to notice here that because we have cos x, and cos x varies between minus 1 and 1, actually the modular signs aren't necessary here, because this is always going to be positive. So in the next step, I'm going to take exponentials of both sides, but actually I'm not going to need my modular signs anymore. So let's take exponentials of both sides. That gives me y is equal to e to the power of ln 1 minus cos x plus c, which is e to the ln 1 minus cos x times by e to the power of c. Okay, just using our index laws. Instead of writing that, I'm going to write that constant e to the power of c as the letter a, and then substitute in my boundary conditions. It tells me y equals 4 when x is equal to pi. So at the point pi 4, 4 is equal to a. Now actually, before doing this, I really ought to simplify this. E to the ln 1 minus cos x is just a times 1 minus cos x. And now let's substitute in this point pi 4. So 4 is equal to a times 1 minus cos of pi. So 4 is equal to a times 2. Cos of pi is negative 1. So a is equal to 2. Let's substitute that back into our equation. We get y is equal to 2 brackets 1 minus cos x. There we go. Part B wants us to sketch a graph for what we got above. We had 2 brackets 1 minus cos x. I think it's going to be a little bit easier if I write that as 2 minus 2 cos x. The way I would go about this is consider, first of all, the normal cos graph. And it asks us to do it from 0 to 2 pi. So this is our normal cos graph between 1 and minus 1. Okay, and now let's change that into the graph of minus 2 cos x. So this means we multiply all of the y coordinates by minus 2. So now when it started at 1, it's now going to start at minus 2 down here. So it's reflecting and stretching. Okay. So now this varies between -2 and 2. Still going through the same points on the x-axis. And then for our final sketch, I'm going to do +2. So this 2 in front is like adding 2 onto this. So 2 minus 2 cos x. Now in an exam, maybe I'll draw these in pencil, and then once I've got my final answer, just neatly rub them out. So because we're adding 2, actually all of it is going to shift up by 2. So now the lowest point, the minimum point on the graph is going to be at 0, and the maximum point is going to be at 4. So it's going to start down here at 0. I'm going to imagine the x-axis to be at 2, and it goes up to 4. So it's going to go through here, here, here. Let's roughly plot out the points we want to get through. 0, pi by 2, pi, 3 pi by 2, and 2 pi. If it helps you, you can even draw your dotted line going through there. But it's only worth 1 mark, so I don't think they want lots and lots of detail there. Okay. Okay, question 5 is one of these questions that we should be familiar with. Some of you will use a bit of a shortcut for these questions, but I always like to write out the formula first. So we have r sine x plus alpha is equal to √7 sine x plus 2 cos x. I'm going to actually grab my formula, because as I said, I always like to do that. So let's write the first bit, x plus alpha. Okay, and the formula is sine A plus B equals sine A cos B plus cos A sine B. So sine A cos B is going to be sine x cos alpha plus, as we said, plus cos A sine B. So cos x sine alpha. Okay, so that is telling me that here you can see that sine x is the same in both, so it means that r cos alpha is equal to √7 and r sine alpha is equal to 2. And that's where our formula for finding r comes from. Because if I square both of these things, r squared cos squared alpha plus r squared sine squared alpha, that is equal to √7 all squared, so 7 plus 2 squared, 4. So r squared brackets cos squared plus sine squared is equal to 11. Cos squared plus sine squared is equal to 1. So I get r squared is equal to 11. So r is equal to the square root of 11. You can do this by straight away using that formula as well. Okay, and I know some of you would prefer to do that. Let's find alpha now. To find alpha, I'm going to divide this one by this one. So r sine alpha divided by r cos alpha is equal to 2 over √7. R divided by r is 1. Sine alpha divided by cos alpha is tan alpha. So tan alpha is 2 over √7. So let's do inverse tan of that now. And we are finding it in degrees to 2 decimal places. So inverse tan of 2 over the square root of 7 37.09 degrees. Let's just ask if the question actually asked us to write it out. It wants the exact value of r, and it just wanted alpha corrected 2 decimal places. So I'm just going to write those two things out at the bottom so they stand out for the examiner. So square root 11, and alpha is 37.09. There we go. Part B of this question is a very common part B for these kinds of questions. I'm going to just write down what we actually had above. So we had root 7 sine x plus 2 cos x. Plus 2 cos x. You'll notice there's a very slight difference. Instead of x, we now have 2 theta. And it says that this is equal to 1. Because it says hence, that means I'm not going to try and solve this. I'm going to use what I've already done. So in our previous part of the question, we found that instead we could write this as root 11 sine x plus alpha 37.09 instead of x, as we just said, we actually have 2 theta, and that's equal to 1. Now, before doing anything else, because I'm now going to use this in another part of the question, I'm going to save this in my calculator memory, this number. So instead of using 37.09, I'm always using this whole number this time. So I'm pressing store, and I can store it in A, B, C, D, E, or F. Let's just store it in A. There we go. Sometimes when I do that, just to help myself and remind myself in the exam, I sometimes write those little letters there to remind myself where I've put those numbers. Okay, let's go ahead and solve this. You will notice we are solving, instead of solving from 0, instead of solving theta between 0 and 180, we actually have 2 theta plus 37.09. So actually, before starting to do this, we need to adjust the domain here. So I'm going to start with theta between 0 and 180. I have 2 theta, so I'm going to double that. So 2 theta goes between 0 and 360. And 2 theta plus 37.09 is between 397.09 and 37.09. You'll see why that's important in a moment. Okay, now going back to solving this, we'll divide by square root 11, so sine 2 theta plus 37.09 equals 1 over the square root of 11, and we'll do inverse sine of both sides. So 2 theta plus 37.09 equals the inverse sine of 1 over root 11. Okay, so I get 17.55. Again, I'm just going to store that, and maybe let's store that in B. 17.55 degrees. And this is the moment where we need to do a cast diagram as soon as we've done inverse sine. So we definitely don't want to start subtracting 37.09 and dividing by 2. We need to do a cast diagram at this moment. Okay, 17.55 degrees is about here. Okay, and this is in the quadrant where sine is, where all of them are positive, sine is positive, so the other place I want is here. And now I'm going to find angles between 37.09 and 397.09. So straight away you can see that actually this one is not within the domains that we want. So the first one we're going to want is going from here to this one here. So 180 subtract 17.55. 180 subtract, recall, there it is, B. So 162.45. Okay, I've stored that in C just to remind myself. And also we're now going to go all the way around 360 plus 17.55. 377.55. Okay, so now we have our two values within our domain. I'm now going to subtract 37.09 and then divide by 2. So let's just write this again down here, 37.09 equals 162.45 and 377.55. You'll notice I stored both of these in my calculator just to be safe. So I'm now going to subtract 37.09 from both of them. Did I store this one? Okay. So 162.45, so C, subtract 37.09, I stored it as A, and I get 125.36. Again, to get my answer as accurate as possible, I'm even going to store this. Actually, let's not do that. Let's straight away divide it by 2 and find out what our final answer is. So divide it by 2 and check the degree of accuracy we want it to. It doesn't say, so it's 1 decimal place because it's an angle in degrees. So 62.7 degrees. And let's find our other angle. So we want 377.55 subtract 37.09. So D subtract A is 340.46, and then divide that by 2 and we get 170.2 degrees. And you can see those are both within the domain 0 to 180 degrees. Question 6 is a partial fractions question. So, as we always do, let's write it as, because we have this letter A here, I'm kind of reluctant to use that letter again, so I'm going to use maybe B over 2x minus A plus C over 3a minus x. These are not improper, there's nothing special about these, so we can just use B and C. Right, let's multiply both sides by 2x minus a times 3a minus x. So we get 5a is equal to B times 3a minus x plus C times 2x minus 8. You'll be used to substituting in things like x equals 1 or 0 or 3. Let's instead substitute in something for, well, let's actually make x equal to 3a, for instance, to get rid of b. So 5a is equal to 3a take away 3a, so nothing, plus c times 2x not 2x, because x is equal to 3a, so 6a minus a. So 5a is equal to 5a times c, so c is equal to 1. And then for the other one, we'll make x equal to a half a to get rid of this one. Because if x is equal to a half a, 2 times a half a is equal to a, so the second one disappears. So x equals half a. So we have 5a equals to b times 3a, subtract a half a, plus c, 2 times a half a is a, take away a, that's why that's nothing. So 5a is equal to b times 3a minus a half a. 3a is 6 over 2a, so we get 5a over 2b. Multiply both sides by 2. 10a equals 5ab. Divide both sides by a. 10 is equal to 5b. Divide both sides by 5. So b is equal to 2. So let's actually express this in partial fractions now, because it doesn't just ask us to find what b and c are, it tells us to write it in partial fractions. So b is equal to 2, so 2 over 2x minus a. And c is 1 over 3a minus x. There we go. Part B is a hence question, so we're going to use the working from above to try and answer this. So let's write out our integral first of all. So we have 2 over 2x minus a plus 1 over 3a minus x with respect to x between a and 2a, and we're going to hopefully show that this is equal to ln 6. Okay, I think a is a constant. I'm just going to double check that. Yeah, a is a positive constant. Now, you may or may not notice, again, this is similar to an earlier question we had on this paper, when we differentiate the bottom here, when we differentiate 2x minus a, because a is a constant, we just get the number 2. So that means when we integrate this, this is of the form ln of 2x minus a. Similar here, when we differentiate 3a minus x, we get minus 1. So that means this one is going to be minus ln 3a minus x, all between a and 2a. Before substituting this in, I might like to combine these into one logarithm. So we have ln 2x minus a divided by 3a minus x, all between a and 2a. So we're substituting 2a into our first one. ln 2a, so 2 times 2a is 4a, so 4a minus a, divided by 3a minus 2a, and in our second bracket, ln, that looks like I've closed the bracket, but it's meant to be a modulus sign, 2a minus a, divided by 3a minus a. Okay, a is a positive constant, and all of these things are positive. 4a take away a is 3a, so I can just write a bracket instead of a modulus sign. 3a minus 2a is a. 2a minus a is a. 3a minus a is 2a. I can divide by that positive constant a now. So we get ln 3 minus ln of a half. And now we can divide these two. So ln of 3 divided by a half times top and bottom of this fraction by 2. And we get ln 6, which is what we were asked for, QED. Question 7 wants us to prove that these two lines are skew. Skew means they are not parallel and they do not intersect. So first I'm just going to show that these two lines are not parallel using their direction vectors. Okay. So to do this, I'm going to take one of the direction vectors, multiply it by a constant. Okay. Maybe I should have written if they are parallel, then this would work. Okay, so we end up with these equations. 2k equals 1 from the I components, minus k is equal to minus 1, and 3k is equal to 4. From 1, you can see that k is equal to a half. From 2, you can see that k is equal to 1, and immediately you can see that there is not one value of k that you can multiply this by to get this. So okay, it's not the same, therefore not parallel. Okay, now I'm going to show that they do not intersect. It's good. So if they intersect, I'm going to write these as single column vectors, so 1 plus 2s, 3 minus s, and 2 plus 3s. So if they intersect, this will equal 2 plus t, 1 minus t, 4 plus 4t. So again, we end up with three equations. 1 plus 2s is equal to 2 plus t. I'm just going to rearrange that and then I'll call it equation 1. So I'm going to subtract t from both sides, 2s minus t. 2 take away 1 is 1. And that's going to be my first equation. My second equation says 3 minus s equals 1 minus t. Again, I'm going to do a little bit of rearranging. So I'm going to add t and subtract this 3, so t minus s is equal to minus 2, that's my second equation, and my third equation is 2 plus 3s is equal to 4 plus 4t. Same again. So let's maybe gather them onto, yeah, same as before. Let's do 3s minus 4t, and 4 take away 2 is 2. And I'm going to use two of my equations to find a value of s and t, and if they are skew, when I try to substitute those values into my third equation, it won't work. Okay, so let's use our first two equations. So I'm going to rearrange number 2 to say t is equal to s subtract 2 and substitute that into number 1. So 2s minus s take away 2 is equal to 1. 2s take away s is s, minus, so s plus 2 is equal to 1, so s is equal to minus 1. And then substitute that back into what we have above. T is equal to 1 subtract 2. So t would also be equal to minus 1. It's important to realise that you will always get solutions for s and t from these first two equations, but it doesn't mean that it's correct. You're just solving two simultaneous equations. If they work in number 3, that means they intersect these two values. If they don't work in number 3, that means they are skew. So you will always be able to find solutions for 1 and 2, but it's all about what happens when you substitute them into the third equation. So 2 plus 3 times negative 1 . And so I'm always not sure what to write here. I'm going to write not equals because I already know that that's going to be the case. So 4 plus 4 times negative 1. So 2 minus 3. 4 plus minus 4 is 0. So minus 1 is not equal to 0. So therefore, they are skew. Okay? Part B wants us to find the acute angle between the directions of the two lines. So for this we're going to need the scalar product or the dot product. And because they are vector lines, as you should know, we are just going to use the direction vectors of the lines, not the position vectors. So our direction vectors are these: 2, minus 1, 3, and 1, minus 1, 4. Whenever we're doing the dot product with vector equations of lines, the bit we're interested in is just the direction vector. 2 minus 1, 3. Dotted with 1, minus 1, 4. Let me just double check those are correct. Yeah. Is equal to magnitude of A, so 2 squared plus minus 1 squared plus 3 squared, 1 squared minus 1 squared, 4 squared, cos theta. Let's evaluate the left-hand side. 2 times 1 is 2. Minus 1 times minus 1 is 1. 3 times 4 is 12. Is equal to the square root of 4 plus 1, 5, plus 9, 14. Times the square root of 1, add 1, 2, add 16, 18. Cos theta. So cos theta is equal to 15 divided by root 14, root 18, and theta is going to be inverse cos of that. So inverse cos of 15 over root 14 times 18. 19.1 degrees. It does say the acute angle, so that's fine. If we ended up with an obtuse angle, we'd have to subtract it from 180 degrees. It's an angle in degrees, so we only need it to 1 decimal place. So 19.1 degrees. Question 8 gives us two complex numbers. It's only 3 marks, so it shouldn't take us too long. Let's write out what we're told to first of all. Minus 4 plus 2i divided by v, 3 plus I. Okay, to separate this out into real and imaginary components, we need to multiply by the complex conjugate of the bottom. So I'm going to multiply the top by 3 minus I and the bottom by 3 minus I. And we're going to do first outside, inside last. So minus 4 times 3 is minus 12. Outside we have negative times a negative is positive, and then we have 4 times I, so plus 4I. The inside terms, plus 6I, and the last terms, I times I is minus 1. We have another negative there, so it's going to be positive, and then we have this 2, so plus 2. Now for the denominator, 3 times 3 is 9. The inside terms we get plus 3i, the outside terms we get minus 3i, so they cancel out. That was kind of the whole point of multiplying by the complex conjugate. And then for the two last terms, I times I is minus 1, times another negative is plus 1. So we're going to get 10 on the bottom. Let's collect our like terms. Minus 12 plus 2 is minus 10, plus 10i divided by 10. So this works out quite nicely. So we just get minus 1 plus I. Part B now asks us to express it in the form RE to the I theta. I think it's always useful to draw a sketch of an Argand diagram in this kind of situation. So minus 1 plus I is about here. And this is the vector that we're looking for. Oops, I missed slightly there. Let's try that again. And that's what we want there. This is our angle theta, and r is the magnitude, the length of this line. So for r, that is going to be the square root of 1 squared plus 1 squared. Remember, it's just the length of this line, so we don't want to be squaring I. It's like in vectors, just to find the magnitude of a line. So here we get the square root of 2 for r, and for our angle, what we're going to do is first we're going to find the angle alpha, and tan alpha is equal to the opposite divided by the adjacent side. So we're forgetting about the fact that this is minus 1 for the time being. We're just imagining it as a right angle triangle with height 1 and base 1. So tan alpha is 1 divided by 1. I'm just checking whether they want it in a particular form. I'm going to do it in radians, I guess. So alpha is equal to inverse tan of 1 divided by 1. Let's change our angle unit. So we get pi by 4, which shouldn't be any surprise. So our angle theta is pi subtract pi by 4. So 3 pi by 4. So u over v is equal to root 2 e to the 3 pi I over 4. Part C is asking us about a geometrical relationship on an Argand diagram. Sometimes these questions can be quite complicated, but this is only 2 marks, so it shouldn't take me too long. Let's first of all write down the complex numbers that we have. So we have u and v, so let's go back and find those. U is minus 4 plus 2i. And we have v. V is 3 plus I. And it wants us to find 2u plus v, so let's figure that out. So 2 times minus 4 plus 2i plus 3 plus I. So minus 8 plus 4I plus 3 plus I. So minus 5 plus 5I. And we're asked to state fully the geometrical relationship between OA and BC. Okay, I might draw just a quick sketch of these just to help me get an idea here. So V is 3 plus I. U is minus 4 plus 2I. And 2U plus V is minus 5 plus 5I. And we are asked to, let's just label these A, B and C as it asked us to do. So A is U, which is here. B is V. And C is 2U plus V. We're asked for the relationship between OA and BC. Looking at it, there's nothing obvious apart from the fact that they possibly could be parallel. So that's the thing that I'm going to check. So let's find what BC would be equal to. So I'm going to do C subtract B. So my C is this, minus 5 plus 5I. Subtract B, which is V. So minus 5 take away 3 is minus 8. 5I subtract I is 4I. And then OA, well, it's going to be A take away 0, and our vector A is minus 4 plus 2I. Yeah, so we can see that they are parallel, and also BC is double the length of OA. So BC is equal to 2OA. I think this more or less explains everything, but I'm just going to write that they're parallel there as well, just in case. Here we need to prove that angle AOB is 3 pi over 4. Let's again do a very quick sketch of the relevant information. So A is our point minus 4 plus 2I, so roughly around here somewhere. So let's just try that again. And B is at 3 plus I. So there's A. Here's our B. Now angle AOB is this angle here. I think the easiest way to find that is going to be to find our angle, this angle here. Let's call that beta, and then we'll find the argument for A as well, and then we'll subtract them to find AOB. So tan of this angle is opposite over adjacent, so 1 over 3. So let's just leave it like this for the time being, tan arctan of 1 over 3. Okay, I'm going to find this angle first and then subtract it from pi to find the argument here. Okay, so let's first of all find alpha. So alpha would be inverse tan of, again, opposite over adjacent, so that's 2 there divided by 4, or a half. Okay, so our angle theta is going to be pi subtract that. And now our angle AOB is going to be our angle theta subtract angle beta. So AOB is equal to this, pi minus inverse tan a half, subtract that angle there, inverse tan of 1/3. So pi minus arctan a half minus arctan a third, which is 3 pi by 4, which is what we wanted. Question 9 looks like the start of an iteration question. Important to notice that here it says x equals f of x. So x equals e to the 2x plus 1 divided by e to the 2x minus 1. To verify that this has a root between 1 and 1.5, the easiest way is to get it all equal to 0. So I'm going to multiply up by e to the 2x minus 1 first. Okay, I'm going to expand this and bring this onto the left-hand side as well. So x, oops, let's fix that. X e to the 2x minus x minus e to the 2x minus 1 is equal to 0. We could actually factorise this, but I'm not sure we really need to. Maybe I'm just going to substitute in 1 and 1.5, and I want to show that there's a sign change between these two values. So when x is equal to 1, we get e to the 2, subtract 1, subtract e to the 2, subtract 1. We can put this, I mean, you could put this into your calculator, but we can work it out pretty quickly. It's actually negative 2, e to the 2 take away e to the 2, minus 1 take away 1 is minus 2. And x is equal to 1.5. This one we might need to put into our calculator, let's see. 1.5 times e to the 3 minus 1.5 minus e to the 3 minus 1. Let's use one more line for this one. So we get 0.5 e to the 3, subtract 2.5, it might be nice, we'll have to work this one out. So 0.5 e to the 3 minus 2.5. There we go. E to the 3 minus 2.5 is equal to 7.54. Okay, sign change shows that there is a root between 1 and 1.5. Part B, it shouldn't surprise us that it now asks us to use an iterative formula. It says based on the equation in part A. So let's have a look at part A. It's this one here. And remember, your iterative formula should needs to have an x on one side and something else on the other side. And if you look at this thing that we've written out here, that's exactly the kind of form that we need. So that's the iterative formula that I'm going to write. So we're going to do x n plus 1 is equal to e to the 2xn plus 1 divided by e to the 2xn minus 1. And for my first value of x, it doesn't actually give us a value to try. So often a sensible thing to do is to use one of the two limits there and check that it converges, and it almost always will. So I'm going to start with 1. I could equally use 1.5, I think, and it should still work. And I'm now going to substitute 1 into that. So e to the 2 times 1 plus 1 for e to the 2 times 1 minus 1. And we want the result of each iteration to 4 decimal places, so 1.3130. And bearing in mind we're trying to find a correct to 2 decimal places. Okay, so now I'm going to go and replace those x's, which were 1, with the answer in both of those. There we go. So wherever I had the x to the n, I now have answer. And I'm just going to press the equal sign and I get 1.1560. Okay, so this is 1.31 to 2 decimal places, this is 1.16 to 2 decimal places, so I need to keep going. Now I've put the answer there, all I need to do is press equals again, and I get 1.2199. This seems to be converging quite nicely. Let's press equals again, 1.1910. And we're getting closer. Here we have 1.22 to 2 decimal places. Here we have 1.19 to 2 decimal places. 1.2035. Even closer, but not quite there yet. This is 1.19, this is 1.20. X7, 1.1980. And now if we look at these two, and if we round them to 2 decimal places, they are both 1.20. So we have determined a correct to 2 decimal places. It is 1.20. There we go. Part C is a slightly uncommon part C for this kind of question. It doesn't really seem to relate to what we've already been doing. We need to find the derivative of f of x. Now it does just say f of x this time, and it's nothing to do with x equals f of x, so it's just this bit on the right, e to the 2x plus 1 over e to the 2x minus 1. E to the 2x plus 1, e to the 2x minus 1. And we're going to differentiate that. We have a fraction, so it looks to me like the easiest way to do this is to use the quotient rule. So u is e to the 2x plus 1, v is e to the 2x minus 1, du by dx is 2e to the 2x, and so is dv by dx. And we're going to use v du minus u dv all over v squared. v du minus u dv all over v squared, which is something that hopefully you remember by now. So v du, e to the 2x minus 1 times 2e to the 2x. I'm going to put the 2 in front. In fact, so I'm going to put the 2e to the 2x in front. Times e to the 2x minus 1, v du, minus u dv, 2e to the 2x times e to the 2x plus 1, all over v squared. Looks like there's going to be some simplification here. Let's multiply out the top. So 2e to the, and we're going to add the powers here, and we get 4x minus 2e to the 2x minus 2e to the 4x minus 2e to the 2x. And I'm just going to leave the bottom as it is for the time being. So this and this cancel, and we end up with minus 4e to the 2x over e to the 2x minus 1 all squared. And we want to find the exact value for which this is equal to negative 8. So minus 4 e to the 2x over e to the 2x minus 1 all squared is equal to negative 8. Let's multiply by the denominator there. So minus 4e to the 2x is equal to minus 8 e to the 2x minus 1 squared. And let's expand this right hand side now. In fact, I'm also going to multiply both sides by minus 1 at the same time, because we have a negative on both sides. E to the 2x squared is e to the 4x minus 1 times e to the 2x and another e to the 2x, so minus 2e to the 2x plus 1. Right, so we have 4e to the 2x equals 8e to the 4x minus 16e to the 2x plus 8. Let's bring that all to the right hand side by subtracting 4e to the 2x, and we get 8e to the 4x minus 20e to the 2x plus 8 is equal to 0. We can divide all of this by 4. I'm going to need a bit more space. Okay, so let's divide it all by 4, and we get 2e to the 4x minus 5e to the 2x plus 2 equals 0. Let's say something like let y equals e to the 2x because here this is e to the 2x squared, because if we raise this to the power of 2, we multiply the powers and we get e to the 4x. So here we get 2y squared minus 5y plus 2 is equal to 0. Does it factorise? Maybe let's just double check the discriminant. B squared is 25 minus 4 times A times C. So 4 times 2 is 8, times 2 is 16. 25 take away 9. 25 take away 16 is 9. So it should factorise. So 2y times negative 2 and y times negative 1. Negative 1 times negative 2 is plus 2, minus y, and minus 4y gives us that minus 5y. So we have two possibilities here. We either have y is equal to a half or y is equal to 2. Let's just go and have a look. The exact value of x, so we're only expecting one answer. Let's see what happens with that then. So from this first one we have y is equal to a half, or we have y is equal to 2. So e to the 2x is equal to a half, or e to the 2x is equal to 2. We'll take logarithms of both sides. So 2x equals ln a half, or 2x is equal to ln 2. So we have x is equal to 1/2 ln 1/2, or x is equal to 1/2 ln 2. Okay, we can do a little bit of rearranging with this. We can write this as 2 to the power of minus 1. So this is equal to minus, and then I'm going to bring the power down, minus a half ln 2. So we have minus a half ln 2 or a half ln 2. So just checking back over at the very start of the question, it says x is greater than 0. And here we have a value that is negative, which is less than 0. So we're going to reject this one. And this is going to be our answer, a half ln 2. Okay, we're kind of used to seeing questions like this as question 10. It asks us to use the substitution u is equal to sine x. So we need to find the exact area of the region bounded by the curve and the x-axis. Now it does give me the maximum point there. It doesn't seem to have too much relevance to this part of the question, so let's just have a look at the second part. Yeah, so the second part is about the point M, so that means we're probably not going to need to worry about it for this part. So to find the exact area of the region, we're going to integrate sine 2x cos squared x between 0 and pi by 2. It wants us to use this substitution. Now, at the moment we have sine 2x. So perhaps even before using this substitution, I'm going to use the formula which we can find in the formula book, which says sine 2a is equal to 2 sine a cos a. So our sine 2x is going to be 2 sine x cos x. So 2 sine x and cos x, and we have cos squared x here as well. So in total we are going to get cos cubed x dx between 0 and pi by 2. And now let's use our substitution. U is equal to sine x. So du by dx, when we differentiate sine x, we get cos x. So our dx is equal to du divided by cos x. So here we have our integral, and I'm not going to put in the limits just yet because we need to change those as well. So we have 2 times u sine x. Let's leave this with cos cubed x for the time being, and then instead of dx we're going to write du divided by cos x. And in fact I will write the limits in, but I'm going to make sure I write that x is equal to 0 and x is equal to pi by 2 because I need to change those into u in a minute. You can see that one of these cos x's is going to cancel out. So from x is 0 to x is pi by 2 of 2u cos squared x du. Okay, we need to change this cos squared into something involving sine instead, which you've probably worked out already is quite straightforward. Cos squared x is equal to 1 minus sine squared x. So cos squared is equal to 1 minus u squared. So let's go back up to the top here. And we'll change the limits on our next step. So between x is 0 and x is pi by 2 of 2u times 1 minus u squared. Okay, for our limits, when x is equal to 0, u is equal to sine x, or sine 0, so u is also equal to 0. When x is equal to pi by 2, u is equal to sine of pi by 2, so u is equal to 1. So our integral now reads between 0 and 1, and let's expand this as well. 2u subtract 2u cubed with respect to u. Now let's integrate, increase the power by 1, divide by that power, and we get u squared. Same again here, increase the power to 4, divide by that, and we get a half u to the power of 4 between 0 and 1. And we get something quite straightforward. 1 squared minus a half times 1 to the power of 4. Subtract, and these are both going to be 0. So we just get 1 subtract a half. So the exact value is a half. Part B, as expected, asks us to find the exact x-coordinate of m. So let's get our equation written down first. It says y equals sine 2x cos squared x. Now m is the stationary point, so we're going to differentiate and set it equal to 0. You can see that this is a product, so we're going to use the product rule. U is equal to sine 2x, v is equal to cos squared x, du by dx is straightforward. Bring the 2 out. When we differentiate sine, we get cos, so we get 2 cos 2x. For dv by dx, a little bit trickier. We're going to use the chain rule, so we're going to bring the power down, so 2, reduce that power by 1, so cos x, and differentiate cos x. When we differentiate cos x, we get minus sine x. Now let's bring that all together in the product rule. So dy by dx is equal to u dv, so minus 2 sine 2x, and I'm going to write sine x, then cos x, and then plus v du, 2 cos 2x, cos squared x. And we know that at a stationary point, dy by dx is equal to 0. So let's set this equal to 0. Minus 2 sine 2x, sine x cos x, plus 2 cos 2x, cos squared x equals 0. Okay, and we're going to need to do some simplification. Now, there'd be a number of ways to do this, but I feel like it's easier to turn everything into x rather than 2x. So what I'm going to do with this sine 2x is turn it into something involving x, and same with this cos 2x. For this sine 2x one, we're going to use the formula sine 2a equals 2 sine a cos a. Let's do that one first and leave the one on the right hand side. So minus 2, and instead of sine 2x, 2 sine x cos x times sine x cos x plus 2 cos 2x times cos squared. Okay, so the left hand side becomes something a bit nicer now, minus 4 sine squared cos squared x Okay, now let's look at this one. So we want to replace cos 2x. Now we have a few possibilities. Here's our cos 2a formula. We could turn it into cos squared minus sine squared. We could turn it into 2 cos squared minus 1. Or we could turn it into 1 minus 2 sine squared. Let's just have a look and have a think. Now, if I turned it into cos squared minus sine squared, I'm going to end up with something involving cos to the power of 4, which doesn't seem very nice. Same if we turned it into 2 cos squared minus 1. I'm going to end up multiplying cos squared by cos squared and end up with cos to the power of 4. Now that might still work out, and I might be able to use a few more identities to simplify it, but at first look, for me it seems that if I use 1 minus 2 sine squared, I'm going to end up with a term involving sine squared and cos squared, and I already have a term like that here. So I think that's the one I'm going to use, and let's see how that works out. So I'm going to use cos 2a equals 1 minus 2 sine squared a, and see if it works. If it doesn't work, we'll try something else. So we have minus 4 sine squared, I missed out the x there we go, minus 4 sine squared x cos squared x plus 2 times 1 minus 2 sine squared x times cos squared x. Let's expand. I keep missing things out, that should be sine squared there. There we go, 4 sine squared x cos squared x plus, now 2 times 1 times cos squared, so 2 cos squared. And then we have 2 times negative 2 sine squared x times cos squared minus 4 sine squared x cos squared x is equal to 0. Okay. So let's simplify these. So we end up with 2 cos squared x minus 8 sine squared x cos squared x is equal to 0. Let's divide by 2. And let's factorise the cos squared out. So cos squared, and we have 1 minus 4 sine squared x is equal to 0. So we either have cos squared x is equal to 0, which is going to give us x is equal to 1, or we have 1 minus 4 sine squared x is equal to 0. So we have sine squared, let me just start that a little bit higher up, so we have a bit more space. So 1 minus 4 sine squared x is 0. So sine squared is equal to 1/4. So sine x is equal to plus or minus 1/2. So x is equal to inverse sine of 1/2, which is pi over 6. Or negative 1/2, which is minus pi by 6. Okay, so we seem to have more answers than we wanted here. Let's just have a look again at what the question asked us. So we're looking for the exact x coordinate of M. So we want x is greater than or equal to 0, but less than or equal to pi divided by 2. Its maximum point is M. So that means that this one, minus pi by 6, is outside the range. So we have either this one here, x is equal to 1, or this one here, x is equal to pi by 6. So from this we get these two solutions. Either cos squared x is equal to 0. So cos x is equal to 0, which gives us x is equal to pi by 2. Or we get 1 minus 4 sine squared x is equal to 0. So a bit of rearranging tells us that sine squared is equal to 1/4. So sine x is equal to plus or minus 1/2. So x is equal to inverse sine of 1/2, which gives us pi by 6. Or when it's minus 1/2, we get minus pi by 6. Okay, so it looks like we've got three solutions, so it's time to have a quick look at the question, see if we wanted more than one answer. It says the exact x coordinate, so I'm only looking for one answer, so let's go all the way back to the diagram. Now it says x is between 0 and pi by 2. Okay, now pi by 2 was one of our answers, and it's there, so that's not the one we want. Another one we got was negative, so it's not that one, so I think the one we want is pi by 6. So we are going to reject this one. We're going to reject this one. And the one we are going to go forward with is x equals pi by 6. Let's check if it just wanted the x coordinate or if it wanted the y coordinate as well. It just asked for the x coordinate. So there we go. We are done. I hope that this was helpful. If you have any requests for specific papers or specific questions, please comment and remember to like and subscribe. Thank you and see you next time.